Hi, welcome to the Introstat lecture series. We are in the testing hypothesis unit, and this is our lecture number 6, the standard deviation as ruler and the normal model. This is our video number 4 here. And on our third videos, we talk about how to find the percentage from the normal distribution for any given z-scores, right? So we talk about you can use the table, or you can use TI-84 calculator, it's pretty handy, or you can use R and just one line simple code here, all right? And now the last video we're going to talk about is how to go backward. What I mean the backward. So if you give me certain percentage, how do I find the z-score associated with that? Okay, so now this one is a little bit harder than the one you given the z-score, try to find the percentages here. Okay, let's go ahead and take a look at our problems here. So we did the previous problems in our lecture video number 3. Okay, so now in here, for this problem here, we said now, I'm looking for the z-score, right? So if z greater than z0 is 1977, so I want to find the z-score. Okay, so the first, let's go ahead and start. Remember, we always want to graph here. So you say here, okay, so this is 0. So you say the z greater than z0 equal to 0.1977. So the first thing to come to your mind, you say, where is my z0? It's on the right-hand side or on the left-hand side of 0? So you say, okay, I don't know. Okay, so you say, okay, how about let's try to put the z0s here to see that work or not. So if z0 is here, then I know the p z greater than z0 greater than, so which area is greater than? This area. So this area, this yellow area is greater than, and I know this cannot be. The reason why is here because the half of it is 0.5. Then this yellow area is greater than 0.5, greater than 0.5, so cannot be 0.1977, correct? All right, so that's why I know this will not be the correct way. So now I say, okay, so now I know here, all right, so this is 0. So I know my z0, where could it be? Has to be on the right-hand side. Okay, so if this is the right-hand side, then they tell me this is the greater than 0. So that means they give me greater than z0s, right? So that's what they give me, these numbers here. This is 0.1977. Okay, so be careful here, right? So because we know the table value and the calculator, the CDF functions, they always use the area. They always use the area on the left-hand side of your z-score. So I need to find this left-hand side z-score. So I know the whole thing is 100%. So my purple one will be 1 minus 0.1977. So what is 1 minus 0.1977 here? Will be 0.8023. So I know this area will be 0.8023. Okay, now I'll be able to find it. Okay, so be very careful. Let's take a look at how do I find it? Let's take a look by using the TI calculator. Okay, so the TI calculator is here. You turn that on, clear that. So you still do second DISTR. But instead of do the normal CDF, I'm go backward. So I say inverse normals here, okay? And now in here, the area, remember this area is always to the left-hand side of your values, right? So here we figured, so this is A023. You get that? Okay, so this is A0 to 3. That's how do you input. And then this is the same, and see here. So what is your Z value? It's A49A65. So it's 0.A49A65. Okay, so let's go back to our worksheets here. And so that's what I get here. So when you go to find the TI calculator, so I find the Z0, the calculator give me is 0.A49A65, right? I cannot put too many, or you can just say that here is approximate to 0.85. That means this z-scores here is 0.85, right? So this is 0.85, okay? Right, so in the TI calculator, what function we use? We still go, right, what here? The second DISTR, then which one we want to use? The number 3s, right? It's INVNORN. Then the area, make sure it's always is the left-hand side area. Okay, so now let's take a look the R models here. So what is the R we're going to use? How do I find it? All right, so let's go to my R studio. And so where is my R studios here? So here, okay, so my R studio is here. Okay, good, back here. Okay, so in here, remember when we give him a z-score, we do what? XPs, right? So now this one is pretty easy. You just say XQ, NORN, and you put the area. Remember, it's the left-hand side area, so it's a point A0 to 3. Then you have a mean equal to 0, and you have a standard deviation equal to 1. How? Did you see here? So that's why in here, they show you here, right? So they show you here, they say, hey, you know, when the x is greater than this value is 1977. That's what we try to find, the 1977, right? So this is A49A65. It's exactly the same. So that's what is my z-zeros here is a 0.A49A65, or it's very close to 0.85. All right. So now in here, okay, so let's go back to my worksheets here. So R, so how do I get a R's here? Okay, so let's try to write it. So my R, so what did it come? We use the X what? XQ, right? XQNORN. And then in here, you put the, I guess I need to have a little bit bigger space here to write it. So, okay, so let me try to write in a little bit bigger space here. So the R, you use the X, okay, so let's see here. This you use the XQNORN, that's right. Then here you put a pointer A0 to 3, XQ, right? And then you set the mean equal to 0, SD equal to 1. And be very careful here. This one's here, A0 to 3, right? So A0 to 3 has to be what? This has to be left area, okay? Then also here, instead of P, you use XQ. Okay, that's what is the R code here. Okay, so now let's take a look the second one here, okay? Hey, the second one, let's take a look at the second problem. And so in here, we want to do what? do graph here. This one is here, you need to be careful here. So this one. So this is 0. Okay, so they give us one off and then they give us 2.32. So here. Okay, so they give us the 2.32 and now it's this one here is equal to the 1768 here. Okay, and now you want to find what is the the z0s here. So z0 could be here, could be there, I don't know. So it really doesn't, so in here, let's say probably is here or probably here, doesn't matter. Okay, so, but you are looking for, we're still looking for the area in between, right? Okay, well, how do I do that? All right, so how do I do that here? Okay, so now let's think, right? Let's use the, let's go ahead, take a look at the TI-84 calculator. All right, so the TI-84 calculator, okay, so here, let's turn that on, clear that. All right, so because they give us 2.32, right, I say second distribution. Right now I go to normal CDF. Okay, so it's half the 2.32. Okay, so my up bound is 2.32. So the lower bound is -1 to the e to the 99. Okay, the up bound is 2.32. Okay, so now you see here, what is here? So 0.9898, right? Okay, so it's 0.9898. Let's go back to my graph here. Okay, so I just used the TI-84 calculator and I get the 0.9898. So which area is 0.9898? It's from 2.32 all the way down, right? So this is the area I just find. Correct? That means this is the area I just find by using the calculator. So what is this area? This area is what? 0.9898. But this area is given. This is 0.1786, right? So if I use 0.9898 to minus 0.1786, what I get in here, I'm getting 0.8112. So which area I'm getting here? If I use this purple one minus this yellow one, I'm getting the area to the left-hand side of z0s, right? So now I can use my functions here. Okay, so let's take a look here. So how do I, get it? So in here, I said, okay, now let's go back to, so it's A112, right? Okay, so let's see here. So now you say the TI-84 calculator, clear that. So you say second distributions. Now I'm looking for the z-score, so I need to go to number 3. All right, so what is the area again? It's the left-hand side area, so it's a point A1. Sorry, here, so it's a point A112, correct? All right, so then, I got my z0 is a point AA23, right? AA23. So that is what my z0s here. So after in here, right? So after this one's here, you put the, so you use the TI-84. What is the function? You use INV norm, right? You use INV norm, you put the area as 0.A112. So you got the Z0 is what? Point what? So AA22, right? So the point AA22, that means this value is point AA22. Clear? Okay. Now let's take a look, right? Let's take a look. How do I use R here? It's the same idea because they always give you is the, the left hand, it's the left hand side. So you already get the A112, right? Okay, so now you can use the R here. Okay. So you can use the R. So the first things here, you still do the same, right? So you use XP NORN, right? XP NORN. Then what is your Z value? 2.32, right? So 2.32. Then you have a mean equal to 0 and SD equal to 1. All right. So here, remember what we did a while ago? Right, so we have, so remember what we did, use the TI calculator is the same, right? So we get a 0.9898. Then you use a 0.9898 to minus point what? 9898 to minus 0.1786. So what is will give you 0.8112, right? So it's the same thing. Now, after you have the pointer A112, and now the next thing is here, you just come here, instead of do SP, so what you do here, you say SQNORN, right? Then you have a pointer 0.8112, then you have a mean equal to 0 and the SD equal to 1. Correct? Okay. And now you can just hit run. Okay, so you say, okay, let's run it, right? So you said, go ahead. See here? So that's why you find, see here, that's why they give you what? They give you the Z-score 0.88. That's why I got my Z0 is 0.88 here. All right. Okay, so that is, you can use, so for this type of problem is a little bit more complicated. So you need to graph it. So you need to, if you use R, so you need to use XP and or XQs, right? And now remember, you always need to put the tail area, the area on the left. So that's why in here you need to kind of minus 0.1786. Okay, after you do a few more, you will feel pretty, I think you will feel very confident about it. It's just remember that, right? So you need to graph. Okay, let's take a look at the application one here. So they said the length of the human pregnancies from the conception to birth, from the conception to birth vary according to distribution. Is approximately to normal 266 days, and the standard deviations is 16 days. What the percentile is frequencies last 240 days. Okay, so let's take a look at this one here. Okay, so that is what here? Let's try to graph it. Now my center mean is how many? 266 days. Correct? Okay, so then they say, what is the percentile last 240? So where is 240? Hey, here is 240. Okay, so that means what is the, what is the percentile going to last 240 days? See here. So that means if you can find what is this area. So what is this area? This is the areas, right? This is the area then not going to last 240. So if you pass this area, going to last more than 240. That's what is my percentiles, right? Okay, so now, you're looking for the area. So what do we need to do? We need to, okay, so let's go to the TI-84 calculator. So let's see here, we find the area, right? So, okay, so now this is pretty cool. We turn that on, clear. Right, so now you say the second DISTR because I'm finding the area, I'm finding the normal CDF, right? So it's always, okay? So the normal CDF, okay, so I'm going from here to here, right? So the lower bound is -1 e to the 99. What is my upper bound here? My upper bound here is 240. Then instead of mean equal to 0, what is my mean for this one? Is 266. And what is my sigmas here? It's 16 here, right? All right, so then you can say here, you go boom. So this is 0.052, right? Okay, so you can find the areas here. So that means this area is 0.052. So that means you say it's about, the 5%, this is the 5th percentiles, right? So this is that means more than 5% will last. Okay, so that will be the 5th percentiles, right? So then, okay, so then, so that's what we say. This is like at what percentiles, right? So we say at the 5th percentile. Okay, so it's this is because it's 0.052, so it's about 5.2%. Will not last. So after 5th percentile, it will last. Okay. Okay, so now let's take a look at the next ones here. So of course you can use this to put it in the R to find it. Let's try to use B, to use the R, so we can kind of flip back and forth, right? Okay, so now here, so excuse me. So for the B's here, remember this is still 266 days, right? Okay, so this is still 260 days. I'm going to find what is the percent, the pregnancy going to last 240 and 270. So which area I'm looking for? I'm looking for this area. That's right, it's in between. Okay, so now for this one, let's try to use the R, try to see, how do we get it? Okay, so this is because we are finding the area. So what the code we use? We say XP, right? XPNORN. So what is, we say C, right? It's between. So what is the between here? 240 days and 270 days, that's right? Okay, and then now you can write down the mean. The mean is equal to what? 266, and the standard deviation is equal to what? The 16. You don't have to, so we are not working the z-score, so you can type the mean of that distribution, right? So it's 266, standard deviation 16, and boom. All right, so now, remember, we love the R because they give us this nice graphs, right? So we said, which one is I'm the one I'm interested here? It's in betweens, right? It's 240. So this color is 1.5466. Okay, so it's 0.5466. Let's go back to our worksheets. So from the R's here, so from the R, I can find this area. This is 0.5466. So we said we have 54.660% of the women, the pregnancy were between 240 and 270 here. Okay, now let's take a look. Let's say how long the longest 20% of the pregnancies last here. Whoa, the longest ones, right? So okay, let's graph it. Always graph it, right? So here, so what is here is 266. Longest 20%. That means here, somewhere here, right? That's what we want to find. How many days will give you the longest 20%. So that means longest 20%. That means this area is what? This area is 0.2 here. Okay, so now let's try to use the, let's try to use the TI-84 calculator and the R both to see how can we do that. Okay, remember, right? So if I want to use it, which area I want to find? I want to find the area on the left. That's what is my input I'm going to use, right? So if the yellow area is 0.2, what is this purple one? Is 0.8. Okay, so now let's see, how quick, how fast the TI-84 calculator can help us to do this. Okay, so now here, turn that on. Okay, clear that out. And so we're finding X, so it's similar like to find Z-score. Okay, second distribution. So which one we use? Number 3. Inverse, no, right? The area, remember, is left-hand side, so it's 0.8. Now I need to change the mean into what? 266. And what is the standard deviation? 16. Now paste. So it's 279.5. Okay, 279.5. So it's about, so let's see here. So from the TI-84 calculator, and from the TI-84 calculator, I can find this X is about 274.5. So it's about what? About 275 days, right? Okay, now let's take a look whether I'm going to get the same thing further by using R. So this will be one more time, try to practice the R. Okay, so now I am looking for the Z-score, right? So I need to use SP or XQ. I'm going to use XQ. XQ, no. Okay, so remember the area is 0.8, right? So I need to put 0.8 is left-hand side. Then I need to put the mean equal to, what is the mean? 266. And the standard deviation, 16. Dun dun. See here? It's pretty cool, right? So they give you what? Here is the answer. It's 279.4. Or is 280 days. So it's exactly the same as we find by using the TI calculator, right? So it's pretty cool, right? And that's it. So that is this lecture about and introduce you to what is the normal distributions about. And then we also spend like 2 videos talk about how to use the technologies, right? Like the TI-84 graphing calculator, or use our software R, or just use table. Like try to find the Z-score to go backward. And like this video, if you use table, it's kind of a little bit hard. And you need to be, sometimes you need to rounding, those things. So that's why I think if you can use the calculator, or you can use R, that definitely, will help you to speed up. Okay. All right, that's it. And that is for this lecture. So now we understand the normal distributions, then we'll be able to continue our journey about the testing hypothesis. Now, the next lecture, we're going to talk about how to test the hypothesis about the averages, about the means here. Okay, all right. So you guys have a good day and nice to talk to you, and looking forward to talk to you again in our next lecture. Okay, bye.